Hey y'all, welcome back. Let's go ahead and review Unit 1. So this whole unit has been all about angle measures and right triangles and most importantly the unit circle, which we'll use to evaluate different trig functions. So let's jump right into it. This whole first section says use the unit circle to evaluate the following, sine of pi over 6 and so on and so forth. So what we want to do is try to locate where that terminal side is and then pull from the coordinates our answer here. So sine of pi over 6, if you look right above, I've got the unit circle right up there, and you'll see that the coordinate at pi over 6 is root 3 over 2 comma 1/2. Now sine is talking about the y coordinate. So just a little, I'm going to make a little note here, or let's make it a little prettier. Okay, just make a little note that's talking about the y. Okay, so at pi over 6, I'm looking over at my unit circle and I see the y value is 1/2. So sine of pi over 6 should be 1/2. And that's all there is to it. You just got to make sure you know which ratio is which and know where to look. Cosine, on the other hand, is talking about the x-coordinate. So what we want to do is look for the x-coordinate where the terminal side of an angle in standard position is pi over 3. So I'm looking at the unit circle. Let's look above there and we see that at pi over 3, the x-coordinate is 1/2. So we actually get the same answer as we got over here. Oops. Let's throw that in an equation, make that look nice. All right, now secant is the reciprocal of cosine. So the reciprocal of cosine, one way to think about that is it's 1 over x, although like I talked about in the homework and in the notes, I wouldn't advise doing 1 divided by the x-coordinate. Instead, just take the x-coordinate, which is most likely going to be a fraction, and just flip it. Change the numerator to be the denominator and vice versa. So, so the reciprocal, let's see, we could look at pi over 6. The x value is root 3 over 2. So the reciprocal of that would be 2 over root 3. Well, let's go ahead and put a square root of 3. Now we can reduce that, and I want you comfortable, I'm sorry, not reduce, but we can simplify that by rationalizing the denominator. I want you comfortable doing that. Hopefully by this point you've sort of identified the pattern here, and you don't need to go through every little step to get there. But anyway, like just to kind of spell it out this one time, and I'll just do it this once. We're going to multiply by root 3 over root 3. Okay, so we're going to multiply by root 3 over root 3 to rationalize that denominator. Wow, it's a pretty ugly 3. Kind of hard to write with the mouse here. But anyway, we get our answer down here. Cosecant of 9 pi over 4. So this is a case where we've got an angle measure that is greater than 2 pi. So you got to revolve more than one full time. And then the strategy that I like to use for this one is just to kind of go around the unit circle. I guess from your perspective, it'd start over here. So like start at pi over 4 and just count your pi over 4s until you get all the way around. If I count pi over 4s as I go as I move 45 degrees at a time, I have pi over 4, 2 pi over 4, 3, 4. If I go all the way around, that'll be 8 pi over 4, and so one more would be 9 pi over 4. To kind of help you visualize this one, let me just kind of show you what the angle measure would look like. So pi over 4 would be here. 9 pi over 4, I would count. So here would be like 1, 2, 3, 4, 5, 6, 7. Hopefully we end up at 8 with one full revolution, and then 9 would be right there. So if I were to sketch this, I'd have one revolution and an extra pi over 4. And so that just kind of helps you figure out what coordinate to look at, which is going to be root 2 over 2 comma root 2 over 2. Now cosecant is the reciprocal of sine, so that is going to be the reciprocal of the y value. So I'm just going to put, for right now, just 1 over y, but just like with secant, don't do this arithmetic here, 1 divided by y. Instead, just flip the fraction, okay, and rationalize as needed. So at pi over 4, our y value is root 2 over 2, so that means that the reciprocal of that would be 2 over root 2. There we go. And then we do need to rationalize that. So just like over here, I'm not going to rewrite it every time like I was saying, but I need to multiply by root 2 over root 2, which gives me 2 root 2 over 2, which This one can be reduced a little further because, as you can see, we've got 2 over 2, which is 1. So this is just going to equal root 2. Okay. The last one here, cotangent of negative pi over 3. So this is another angle measure that's not between 0 and 2 pi. This one's negative, so we need to rotate in the clockwise direction. And just kind of show you what that would look like so you can get a good visual here. Pi over 3 would be like right about here. You can see it above where pi over 3 would be. So instead of rotating counterclockwise, I'm going to rotate clockwise, which puts me roughly here. The angle which is coterminal to negative pi over 3 is 5 pi over 3. So you don't want to be looking at that coordinate at 5 pi over 3. Cotangent is the reciprocal of tangent, which is y over x. This one is x over y. So we're just going to take the x-coordinate divided by the y-coordinate. If you've been watching these videos I've been recording, you've noticed that, hopefully you remember that you can ignore the denominators when you divide x by y because they'll both cancel out. And so really just looking at the numerators here, the x-coordinate at 5 pi over 3 is going to be 1/2. I'm going to ignore the 2 and just say 1 divided by, what would that be? Let me go back, negative root 3. So this is something that we are going to have to simplify by rationalizing the denominator again. There we go. So I'm going to multiply by root 3 over root 3, and that should result in 1 times root 3 is just going to be root 3. Oh, well, change the colors on me. Let's try that again. It's going to be root 3, and then over 3, and the whole thing will be negative. Okay, so that's how you use the unit circle to evaluate trig values. Okay, let's do some triangles. With these triangles, we're trying to evaluate the trig ratio. So this, make sure you know your, SOHCAHTOA ratios. Sine is the opposite over hypotenuse. Just to kind of run through these real quick. Tangent is going to be opposite over adjacent. And then finally, cosine is going to be adjacent over hypotenuse. So really it's just making sure you know what those ratios are here. I'll just make a little note. I like making these little notes on the review just so that when you look back at it, you can kind of see what do we do there. So, so if this is our angle in question, this angle right here, the opposite side is going to be down here and the hypotenuse is here. So what we're going to have to probably do on most of these is use the Pythagorean theorem to find that missing side. I'll do it on the first one just to kind of save time. Well, you know what? Let's just go ahead and do them all. I backtracked pretty fast there. So 12 squared plus, we'll call it the opposite side squared, equals 20. Now I'm going to kind of skip through the algebra here. We've done a lot of Pythagorean theorem. Hopefully you're comfortable solving this. Basically you're going to square everything. You're going to subtract the 144 and then take the square root. And what you end up getting is that the opposite side is 16. So sine of x, which is opposite over hypotenuse, is going to be 16 over the hypotenuse, which is 20. Okay. For this next one, tangent is opposite over adjacent, so we need to find this opposite side. We'll do basically the same thing as we did before. We've got 16 squared plus the adjacent. Wait a minute. Which angle are we looking at here? I'm trying to work too fast. Yeah, it's this one. Okay, so it is the adjacent. Just want to make sure I got that right. The adjacent squared equals 34 squared. The solving process here is going to be the same. I'm going to skip the algebra here just for time's sake. And, again, you're going to square these, you're going to subtract, and then you take the square root of what you get there. And you actually end up getting 30. So far, we're on a roll here with Pythagorean triples. No square roots. So that's pretty cool. I don't know. I find it, anyway. So tangent's opposite over adjacent, so that's going to be 16 over 30. Now it looks like I kind of went too fast here. Looks like this can be reduced, just like this one can be reduced. right? 16 over 20 is going to be 4/5. 16 over 30 will be 8/15. So and you want to make sure that you can reduce those. Cosine is going to be adjacent over hypotenuse. So if we're doing cosine of x, which is this angle right here, the adjacent side's 12. We don't know the hypotenuse, but we can solve for it. Once again, using Pythagorean theorem, we have 12 squared plus 9 squared equals the hypotenuse squared. Let me drag that over so we can kind of fit it on there. Yeah, that's good enough. And then, so our hypotenuse, if we solve that, again, so this one will be a little different. You don't have to do the subtraction like we had to do over here. Just square, add these together, and then take the square root of both sides, and you should get 15. So the cosine of x is going to be, let's see here, the adjacent side, which is 12, over 15. Okay, this is another one that can be reduced. We get 4/5. All right, so if you know two sides of a right triangle, you can solve for the third one using Pythagorean theorem and use that to evaluate your trig ratio. One of the things we did, was it? I think it was the first day of this unit, maybe it was the second, but we were able to, no, you're right, it was the second one, second day. Regardless, what we're doing is we're converting from radians to degrees and vice versa. So if you're going from radians to degrees and you have this pi right here, it ends up being pretty easy to convert. You just replace that, what's going on here? Replace that pi with a 180 and then just do the computation. So 3 times 180, and just to be careful here, I'm going to use a calculator. All right, so let me break out the old TI calculator here. If it will come up, there we go. Okay, so I'm going to do 3 times 180 divided by 5. Oops. Not, oh, come on. Wow, okay, that took way longer than I thought it would. All right, 108. Okay, so 108 degrees, no big deal. So that's kind of the trick here is if you're going from radians to degrees and you have it in terms of pi, you can just plug in 180 for pi and you're done. Now, if it's not in terms of pi, if I say something like 2 radians, you're going to have to do the proportion, okay, which I'll show you over here. So it says express 48 degrees in radians. So this is where you would set up a proportion to solve using a conversion that we know, which is that pi radians is equal to 180 degrees. So we'll use that ratio, and then we'll use it to convert this 48 degrees. So I'm going to put the radians on top, because that's where pi is, and the degree on bottom. So that's why the x is on top, and the 48 degrees is on bottom. If you were going from radians to degrees, and you can't use this trick, like let's say, like I said before, if you have 2 radians, you'll just put the 2 here and the x down here and solve it like we're going to do over here. And I just realized my calculator is covering everything up, so let's get rid of that. So anyway, pi over 180 equals x over 48. We are going to cross multiply, which is going to give me 48 pi equals 180x. Then we will divide both sides by 180. And we essentially get our answer here, 48 pi over 180. We do want to simplify it though. So let's see, if we simplify that, let's see, 48 over 180, I might just use the calculator to do that. So let's pull that up, and I'll just remind you how to use the calculator to reduce fractions. You hit alpha, y equals, enter, and then you can just type in the fraction. So ignore the pi here because that's gonna screw it up. Just do 48 over 180. So we're really only interested in reducing that coefficient, 4 over 15. So yeah, what we get here is 4 over 15, or 4 pi over 15. And that's in radians. Okay, so that's how you convert radians and degrees. Let's take a look at number 5. It says find the missing side x. So this is where we're going to set up kind of an equation like we did here in number 2, except we'll be looking for a missing side. We'll be actually solving for x here. So for this first one, we've got 46 degrees. We know the opposite side, and we're interested in the hypotenuse. So in that case, we will use sine. Okay, we'll say sine of 46 equals the opposite side over the hypotenuse. So 8 over x. So if I solve for x here and I isolate it, what I'll do, the technique here is to multiply both sides by x to move this over here, and then divide by sine of 46. So 8 ends up, or x equals 8 divided by the sine of 46. This is something you'll put in the calculator, so don't feel like you need to know what that equals off the top of your head. We'll say x is approximately, make sure you're in degrees as well. 8 divided by sine of 46 should be about 11. I'll go 3 decimal places here. And that's the length of the hypotenuse. For number 5, let's see here. So we've got this angle right here. We're looking for the opposite, and we know the adjacent. So that tells us we're going to use tangent. Tangent of 23 degrees equals the opposite side over the adjacent. So if we're solving for x, and x is in the numerator, instead of like multiplying x and then dividing by this trig function, we're just going to multiply both sides by 6. So x is going to equal 6 times the tangent of 23 degrees. Again, that's something you're going to put in your calculator. Just type it in and make sure that you are in degrees again, because this problem is in degrees. And let's see, what did I get? 2.547. Is it going to let me edit this? Come on there. There we go. I just didn't want to have to read. All right, anyway, 2.547. It should be the length of this short side. So there's number 5. Number 6 is going to be a word problem, and most of these word problems that we're going to see are just going to be you setting up a right triangle and solving it kind of like we did above. Sometimes you'll need the angle, sometimes you'll need the sides, but you really got to read carefully to figure out how to set it up. So it says Duncan is flying a kite. The length of the kite string is 30 feet when the kite is 10 feet above the ground. Okay, so let's just start sketching. Here's the ground. Here's the height. So basically, let me move this over a little bit just to kind of clarify what's going on here. So we got Duncan. So we'll put Duncan as D. Okay, we'll just say Duncan D. And the length of the kite street is 30 feet. So this would be 30 feet. The kite is up here, so I'll label that K. And Eloise is standing directly below the kite, so I'm going to put this E. So we've got Duncan, Eloise, and the kite. And it says the kite's 10 feet above the ground. And we want to know the distance between Duncan and Eloise. So I'm going to put an X there. So the trick here is really just making sure it's set up properly. From there, we're just going to solve it like we did above. The problem's not really that hard, except you really have to pay close attention as you're reading it and making sure that your diagram looks correct. So actually, we don't even need to use the trig functions here. We're just going to use Pythagorean theorem. This one's going to be a little bit easier, I think. So yeah, we've got 10 squared plus x squared equals 30 squared. I'm going to forego the algebra here. Hopefully that you've done enough of these Pythagorean theorem problems to know how this is going to work. Square both of these, subtract the 100, and then take the square root, and we should get approximately, let's get that approximate symbol going, 28.284 feet. I'll just abbreviate. I don't know why it doesn't let me do a space in there. It's kind of annoying. Oh well. You know what I can do? It's going to look a little sloppier, but at least there'll be a space there. I'm probably overthinking it, y'all. Okay, feet. Okay. So there you go. So that's how far Duncan and Eloise are from each other. Let's go to the next page. We got another word problem here. It says a ship is sailing due east. Okay, so that's like to the right. Captain sights a buoy up ahead at an angle of 25 degrees to the right of the path. So that would be like from their perspective, that would be like this way. Okay, so almost like we're doing a negative angle measure here. So 25 degrees is going to be, something like this. It doesn't have to be perfect. Just get rid of that to make this look a little nicer. So there's a buoy down here. I guess I'll label that with a B. Well, I guess I'll just write buoy, I guess, because boat also starts with, oh, I guess ship can be S. Okay, so I'm going to go with B. All right. 25 degrees, so let's go ahead and label this 25 degrees. That's pretty ugly, but yeah, let's clean that up a little bit, jeez. By radar, she determines that the shortest distance to the buoy is 9 miles from the ship. So that would be this side right here. So 9 miles. Draw a diagram that represents the situation. Okay, I think we pretty much got that. I'm going to do a little right angle here. All right, part B. Assuming the ship doesn't change direction and the buoy stays stationary, calculate the closest will come to the buoy. So if the ship keeps going this way, going east, the closest it'll ever get to the buoy is when it's right here, right at this vertex. So what this is really asking for is this distance right here. Okay, so if this is the angle in question, this 25 degrees, and I'm looking for the opposite side and I know the hypotenuse, I'm going to use sine. So I'm going to say sine of 25 degrees equals x over 9. We'll solve this by multiplying by 9 on both sides. So x will equal 9 times the sine of 25. And then, so we could put that in the calculator and get approximately, okay, let me type that in real quick, 3.804 miles. So not really that close. 3 miles, that seems like pretty far. Okay, so yeah, and then part C, how far must the ship travel to reach this closest point? Okay, so this is really asking for this side up here. Okay, so in this case, I would not use this side just in case you made a mistake on part B. Use the side that's given so you know that that number, there's no problems with that number. So if this is the angle we're working with, and we know the hypotenuse, and we're looking for the adjacent side, let's use cosine. So we'll say cosine of, cosine of 25 is x over 9. So we'll solve it exactly like we did the last one. We're going to multiply both sides by 9. So you get 9 times the cosine of 25 equals x. I like the x in front. X equals 9 times cosine of 25. And then we can just put that in the calculator. And let me, oh gosh. I hate it when it does that. I don't know why it does that. One moment, please. Oh gosh. Now I'm just deleting everything. This is starting to turn into a disaster here. All I wanted to do was just copy and paste. That's it. Okay. Gosh, make this so complicated. Okay, anyway, type that in your calculator. You should get 8.157. And there's the ship problem. Okay, so again, the tricky part here is making sure you're reading the problem correctly and drawing the diagram accurately. Number 8 says Scott's looking at the top of the cell of Scott is looking at the top of cell tower. Okay, I think there's a word missing in there. Top of a cell tower at an angle of elevation of 25 feet. All right, so what we've got here is we've got our good friend Scott standing 150 feet from the base of the tower. Here's the tower. Here's your angle of elevation. Is it the same angle? 25 degrees? Huh. Well, I might change that for next year. Anyway, he's standing 150 feet from the base of the cell tower. So we're going to put the cell tower here. Okay, the cell tower, how do I want to label this? Tower. Kind of hard to write this with the mouse sideways. Oh, jeez. Especially with the computer lagging like that. Okay, anyway, so 150 feet, how tall is the tower? Okay, so there's our x. That's what we're looking for. This is another one of the same kind of problems. Again, just it's good practice to be able to read these and interpret them. Here we're going to end up using tangent. of 25, whoa. Tangent of 25 equals opposite over adjacent. Wait a minute, what happened to my triangle? It just disappeared. Okay, no biggie, I can just rewrite it. That is bizarre. Okay, I must have pressed something. Must have did a undo or something when I wasn't thinking. No worries, I'll just... Lost the 2 somehow too, and then I'll put an S for Scott. Okay. Whew. Anyway, we're going to multiply both sides by 150. So you get 150 times the tangent of 25 equals x. And again, just throw it in your calculator. Okay, there's going to be some calculator problems on this test. There will be some non-calculator, but stuff like this will always require a calculator. So if I do 150 times tangent 25 in my calculator, I get about 70 feet. Now, the reason why I'm not going 3 decimals here is because it tells me specifically round to the nearest foot. So, you know, sometimes it won't say, whenever it doesn't say, I usually go 3 decimal places because that's what the AP test next year is going to require. But, you know, if it says nearest foot, then we'll do nearest foot, no big deal. Can I make this smaller? I guess not. I feel like I should be able to. Who cares? Oh, wait, there we go. Just make it look a little nicer. All right, let's move on here. We're on number 9. Number 9, if sine of theta is 3/5 and, obtuse. Okay, so if it's obtuse, that means it's between 90 and 180. If it's between 90 and 180, we are in quadrant 2. Okay, so this right here means we're in quadrant 2. Okay, so when I draw my diagram here, I want to have an emphasis on quadrant 2, and my triangle is going to look like this. Now, what ends up happening is, you know, your cosine, or that adjacent side, we're going to label with a negative. Right? Here's theta right here, so our reference angle is right here. Okay. Okay, so sine is 3/5. That means this is 3. This is 5. We can use the Pythagorean theorem to find this missing side, which ends up being 4. I can see that right away because I know my 3, 4, 5 triangle. But just be careful here because we are in quadrant 2, so this should be -4. So the value of tangent theta, which is opposite over adjacent, the opposite side here would be 3, the adjacent side would be -4, so it should be -3/4. So tangent of theta equals -3/4. Okay, number 10. This is where it starts getting tricky, and this is just going to kind of guide you through it. But it says, what quadrants could the terminal side of angle theta be in, given these conditions? So if cotangent is positive, cotangent, if you recall, is the x divided by y, right? And so in order for that to be positive, either both of these have to be positive or both of them have to be negative. So they're both positive in quadrant 1, and they're both negative in quadrant 3. So if cotangent's positive, then you could be in either one of these, and we would need like some other bit of information to narrow it down. Sine is referring to the y-coordinate. So we're looking for where's the y-coordinate negative, and the y-coordinate would be negative in either quadrants 3 or 4. All right, so C is going to be like more like what your questions are going to be, more like how the questions will be written, because, you know, like A and B, it only narrows it down to 2 quadrants. We need to narrow it down to a single quadrant usually to solve this. So like number 9, you know, some kind of information to really narrow it down. And so a lot of times I'll give you 2 pieces that you kind of have to put together to figure out where you are. So tangent is y over x. It's going to be positive and negative in the same places that cotangent was, because in order for this to be we're doing negative here. But yeah, the same thing applies. If this is negative, then one of these 2 things has to be negative and the other has to be positive. So that's going to happen in quadrants, let's see, if that's going to be negative, that would be quadrants 2 or 4, okay? And then if cosine is negative, cosine is referring to the x value. So that'll be negative in either quadrants 2 or 3. So if I use a little logic here and I determine where do I have to be, well, if this is in quadrant 2 or 4 and this one says I'm in quadrant 2 or 3, then we're in quadrant 2. Okay. Can I just circle that? Oh my gosh, this lag is killing me on this mouse. I don't know why. Here, I'm just gonna, whoa, okay. Let's just do this. Oh, and it deleted my text. I don't know why it keeps doing that. Okay, quadrants, what did I say? Negative in 2 and, wait, cosine's negative in 2 and 3. So we are in quadrant 2. Okay, so yeah, A and B narrowed down to 2 different options. Why in the world does it keep deleting that? It's so bizarre. Yeah, so A and B narrowed down to 2 different quadrants, and because we have 2 pieces of information for part C, we're able to narrow down to a single quadrant. All right, this number 11 is kind of an interesting question. It says, is it possible for an angle measure to satisfy these conditions, that sine of theta is root 3 over 2 and cosine theta is root 2 over 2? And the answer here is no. Okay, that's not possible. No, because that first equation, there's only 2 places where sine of theta is root 3 over 2. In the first equation, theta is either, I'm going to try to do this pi. I wonder if I can, did I type pi ever before? Yeah, let's borrow this pi real quick. And I'm just going to type this, try to move quickly through here. I know this video is already getting kind of long. In the first equation, this sine theta one, theta either has to be at pi over 3. Oh, it didn't like it. Didn't like my pi. Well, I'll just type it like this. Pi over 3 or 2 pi over 3. Okay, you can see above on the unit circle where the y value is root 3 over 2, and it's at those 2 angle measures. And in the second equation, cosine being root 2 over 2 is only going to happen at pi over 4 and 7 pi over 4. So that, there's not a single angle measure that will satisfy both of those. Okay, so how do I want to word this? No, because in the first equation, theta is either pi over 3 or 2 pi over 3. And in the second, theta is either, we'll say, pi over 4 or 7 pi over 4. Now, it might be an angle coterminal to that, but those terminal sides are not in the same location. Pi over 3, 2 pi over 3, pi over 4, 7 pi over 4. So there's no single angle measure that will satisfy both of these simultaneously. All right, last page here. We're going to practice with some more angles. All right, number 12 is a little bit more practice like we had in the very beginning, where we're using the unit circle to determine these values. So I'll run through these pretty quick because they don't really take a whole lot of thought. Let's see. Cosine, we're talking about the x. Secant, we're doing the reciprocal of x. Sine is y. Cosecant is the reciprocal of y. Cotangent is going to be x over y. And then we'll knock out this one last. We'll talk about that when we get to it. So look at 5 pi over 6. Okay, you see 5 pi over 6 right up there, over there, right above the pi. And if we're talking about the x value, it's going to be negative root 3 over 2. So as long as you know where to look, these questions should be pretty fast, honestly. Okay, so that's negative root 3 over 2. Now, secant is the reciprocal of the x value. So at 2 pi over 3, let me look up there. So 2 pi over 3 is in quadrant 2, and the x value is negative 1/2, so the reciprocal of that would be negative 2. So you'd say negative 2 over 1, which equals negative 2. So sine of negative pi over 6, negative pi over 6 is coterminal to 11 pi over 6, right? Because you're rotating in like here you're rotating downwards, pi over 6. So you can see how it would be coterminal to 11 pi over 6. And we're looking at the y value there, and the y value is negative 1/2. Cosecant of 135. So 135 you can find in quadrant 2. And cosecant is going to be the reciprocal of the y value. The y value there is root 2 over 2. So that would be 2 over root 2. And what we saw on a previous problem is that we can rationalize that denominator, multiply this by root 2 over 2, or root 2 over root 2 rather, and then what did it simplify down to? Let's see. I thought we did that one already. Did we not? Maybe we didn't. Oh, I guess not. Could have swore we did. Maybe it was like on a homework or something. But anyway, so we multiplied by root 2 over root 2, and this just simplifies to be root 2. Cotangent of pi is x over y. So look at pi, which is going to be like over here. You can see it right above. The x value is negative 1, and the y value is 0. So it's like negative 1 over 0, right? Which you can't divide by 0. So we're just going to say undefined. No value. Tangent of 0 plus, so we're going to evaluate these two separately and then add them together. So tangent of 0 is going to be the y over x. Is this going to be undefined as well? Tangent of 0? Oh, no. Because it's 1 comma 0. Okay, so tangent of 0 is going to be 0 over 1, which is just 0. And then sine of pi over 2, so 3 pi over 2 is the y value is going to be negative 1. So it's going to be 0 plus negative 1 equals negative 1. This takes us back to the first couple days when we were sketching angle measures, number 13. So 120, hopefully you have a good idea where that is now, since we've been working with the unit circle so much. But yeah, 120 degrees is going to look like this. Don't forget that rotation notation, most important part of the whole diagram. Okay, you got an arrow going to it, kind of like that. Okay, 344 is going to be in quadrant 4. Okay, somewhere over here, right? Because 330, it's almost actually 360. Yeah. So my arrow is going to go all the way around, point to it like that. Negative 5 pi over 3 is going to be coterminal to pi over 3. So just kind of point pi over 3, rotate clockwise. 17 pi over 8, this is where it gets a little tricky, right? But I think we can handle it because as a little quick note here, 16 pi over 8, that's 2 pi. So if I have 16 pi over 8, that's 1 full revolution, right? 17 pi over 8 would just be like 1 more than that. So that's even less than pi over 6. So the terminal side is going to be in quadrant 1, just like kind of barely above this. I'm going to do a full revolution. Oops. Yeah, I don't know why it's kind of glitching here. Okay, so let's see. 1 full revolution, and then I'm going to try my, here, let's see if I can just zoom in. Might make this a little easier. And then draw a little arrow here. That looks pretty bad, but it should be pointing like to this terminal side. 1 full revolution and then go around a little bit. But yeah, okay, so there you go. Zoom back out a little bit so you can see everything. There we go. Okay, that's it. Those are your sketches. Number 14, the terminal side of angle theta passes through the point -3, -5. So that -3, -5 business means that we're in quadrant 3. Okay, -3, -5 will be somewhere down here. We don't need to know exactly, but the triangle we're going to draw is going to look something like this. Okay, so -3. Now, to be able to actually answer these, we're going to need to know the hypotenuse. So we'll use the Pythagorean theorem, and we get root 34. Okay, I'll spare you the algebra. Let me know if you have any issues using Pythagorean theorem. But once you solve for that missing side, now we can go ahead and calculate all these. So cosine is adjacent over hypotenuse, so that'd be -3 over root 34. Okay, but we can rationalize the denominator there, and we get negative 3 root 30, oh, come on, root 34 over 34. All right, so it would be negative 3 over root 34, but when you multiply by root 34 over root 34, this is what you get. Guess we don't need that equal sign there. A little redundant. Okay, so cosecant is the reciprocal of sine. So sine would be opposite over hypotenuse. So the reciprocal would be hypotenuse over opposite. Okay, so hypotenuse over opposite is going to give us, come on, click on there. There we go. Don't need the equal sign again. Negative root 34. Every time I click on that, it gets me out of the box. Gotta get used to that. 34 over 5. What the? There we go. Okay. All right, there you go. Number 15, the terminal side of angle theta is in quadrant 3. Oh, that's kind of nice. They just come out and tell us what quadrant it's in. So I'm going to go ahead and start sketching my diagram here. You know, that's usually a good place to start. Quadrant 3. So somewhere down here, here's my triangle. Okay, if cotangent is 5 over 2, determine the following. Okay, so first of all, cotangent is x over y. So this should be 5 over 2, but be careful because we are in quadrant 3, so both of these need to be negative. So if we were to divide these, it would end up being positive, which is why this is okay, that we don't really have any issues with that. But just make sure you label these as negative. Now when you go to use the Pythagorean theorem to find that missing side, what we're going to get here is the square root of, why does it keep changing colors on me? I don't like that. Square root of 29. And so from here, we are just going to come up with the correct ratio. So sine is going to be opposite over hypotenuse. So the reference angle is right here. So it would be negative 2 over root 29. But when you rationalize that, you're going to get negative 2 root 29 over 29. So we used to put in that equal sign in the front. I guess I don't really need to with most of these because they have the equals. Okay, so cosine is going to be the adjacent over hypotenuse, so that will work very similarly. We're going to get negative 5 root 29 over 29. So it would be negative 5 over root 29, but just remember we got to rationalize that denominator. Finally, tangent is going to be y over x. So that's going to be, or opposite over adjacent, negative 2 over negative 5. It's just going to be 2 over 5. We actually didn't need to do a diagram to find that out because we know that tangent is just the reciprocal of cotangent. So we just flip that fraction on that one. Okay, there we go. We only got a couple problems left here. Let's take a look at number 16. So for number 16, they say secant is positive. Now, secant is positive wherever cosine is positive, and cosine is positive in 1 and 4. So this is going to, geez, I'm just going to type that. It looks so terrible when I'm trying to write with the mouse. Okay, so yeah, so this is going to put us in either quadrants 1 or 4. And then sine being negative, that's where the y value is negative, that's going to be in either quadrants 3 or 4. So we have to be in quadrant 4, right? Got to be in quadrant 4 because that's going to be the only one that would satisfy both of these conditions. So before I even go further, I'm going to go ahead and sketch out a diagram with an emphasis in quadrant 4. Okay, I'm going to draw my triangle with my reference angle. There's my reference angle right there. It's supposed to be a right angle. Okay, so secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So this is actually hypotenuse over adjacent. So the hypotenuse is 4, adjacent is 3. We can use the Pythagorean theorem once again to figure out this side. Now note that this is negative. So when you use the Pythagorean theorem, just make sure you slap on the negative sign at the end. It should be negative root 7. All right, so let's go run through these. Sine is opposite over hypotenuse, so that would be negative root 7 over 4. Tangent is opposite over adjacent, so that would be negative root 7 over 3. And then cosine is adjacent over hypotenuse. Adjacent over hypotenuse. It's going to be 3/4. It should just be the reciprocal of secant, which was actually given here. But it's nice to see that confirmed with our diagram. Okay, yeah, there we go. Last problem here. We're naming some coterminal angles. So remember, coterminal angles are angles that have the same terminal side. So the strategy to find coterminal angles is going to be to either add or subtract one full revolution in the appropriate units, and we'll get our answer. So for example, 135 degrees, if I add 360, so maybe I'll just, I want to, in this case, I'll just type it out. Okay, so either add or subtract one revolution. So that would be either 360 if we're doing degrees, or 2 pi if we're working with radians. You might have to do it more than once. This is just a guide because, like for instance, negative pi over 6. Actually, I think it'll work on all these. But let's just say you're trying to get a negative angle measure. You might need to do it more than once if the angle measure is greater than 2 pi or 360. So just be prepared to do that. So let's see, 135 plus 360 is going to give me 495 degrees. And then if I subtract, if I do 135 minus 360, I should get negative 225. So that's one positive, one negative coterminal angle. For 3 pi over 4, if I add 2 pi, I'm going to get 11 pi over 4. Right? 2 pi would be like 8 pi over 4, and 3 plus 8 is 11. 3 minus 8, on the other hand, would be negative 5. So we get negative 5 pi over 4. So we've satisfied the conditions, one positive and one negative. These are both coterminal angles, and these are both in radians. Maybe I should type that in. And then if I add to, if we're in pi over 6, if I add 2 pi, that would be like adding 12 pi over 6. So negative 1 pi over 6 plus 12 pi over 6 would be 11 pi over 6. Now if I did 1 pi over 6 minus 2 pi, or minus 12 pi over 6, that would give me negative 13 pi over 6. Now, I do want to make sure you understand that your answers may be different here, because you could just add an extra 2 pi or add an extra 360 degrees and get another coterminal angle. This just says, one positive. So if I add 360 to this, I'll get another positive one, and then we'll be okay. On the test, I'll be a little bit more specific about which ones because, we're taking these in Schoology, and so I'll be looking for one, angle in particular, most likely. Just be aware that you want to be able to satisfy this condition. And also, just know what coterminal means. Okay, coterminal means that their terminal sides are in the same place. Well, that's it for the review. Make sure you practice not only these problems, but the practice problems that are posted in Schoology, and you should be good to go. As always, let me know if you have any questions and I can help you out. But other than that, y'all have a great day, and I'll see you next time.